Hello everyone, this is Direwolf20 and I'm here doing a brand new mod spotlight on a mod that I've spotlighted once before a long time ago, but it's come a really long way since the last time I did this mod spotlight, and it's about time I do a new one and start getting used to playing with it because I do have intentions of using it in the near future. It is time to do a mod spotlight on, dun dun dun, ComputerCraft. ComputerCraft is a really cool mod that adds computers to Minecraft. They're craftable. There's a bunch of different things you can do with computers, and I've set up some examples around the world here to help show you guys how these different things work. It also adds turtles to the game, which is basically a movable form of computer that you can program just like a computer, but it can move and do all kinds of cool stuff. There's all kinds of neat things you can do with ComputerCraft, and really this mod spotlight will not even touch or scratch the surface. I'm going to try and show you guys all the basic functionality, but not go too in depth, but basically give you an idea of how this thing works. So without further ado, let's start looking at ComputerCraft. Alright, so the very first thing you're going to need to do to play with computers in ComputerCraft is craft yourself a computer. Pretty simple and straightforward, and you can see the recipe right here. The recipe is pretty easy to make, and when you craft yourself a computer, you can simply place it down. Boom, just like that. Alright, when you right click on it, it's actually going to start the computer for you, and you can see it's CraftOS 1.4. Now the best thing about ComputerCraft is the help system. Just type help. And it is awesome. It'll tell you everything you need to know about programming and all that stuff. So if you don't know how to do stuff in ComputerCraft, the help screen is definitely the place you want to go. You can also go visit Dan200's ComputerCraft thread. He's got a link to a wiki where everything is pretty much laid out for you. If you want, you can see a list of built-in programs. For example, I'm going to type programs just like it says right up here. And when I hit enter there, you'll see a list of all the different programs that are available. And there's a couple cool ones and a couple simple ones, and a lot of them built in are basic functionality, but a couple demonstration ones as well. You can also type APIs to see a list of all the APIs that you can use while writing your own programs. So instead of just using the built-in ones, you're probably going to want to write some yourself to do all kinds of cool stuff. The programming language in ComputerCraft is Lua, or L-U-A, and it's basically a pretty simple language to pick up if you want to get into programming. It's a nice one to start with, and it's really pretty straightforward. It's a nice high-level language. Now, one of the important things you're going to want to deal with first with a computer is checking out what the computer ID is. When you type ID, you'll see that this computer is number 21. The reason for that is I've created about 20 computers in the past already. You can see them all over the world here. And if you look at that computer number 21, you're also going to want to look in your world save folder in your .minecraft and then your saves folder. You'll see inside your world save, there's a folder in there. And inside that folder, there's subfolders for each computer you create. Now the thing about this is if you break a computer and then place it back in the world, it's going to basically act like a brand new computer. So now you can see that this is computer ID 22. Each computer has its own kind of hard drive built in where all the programs you write on it are stored. So if we wanted to, we could just type ls here to get a listing of all the programs. You can see there's a ROM folder already. This is the read-only memory area where you can see the APIs and the help and the programs and all that stuff. But if we go back down a level, you can see that we're back now at the root. And if we wanted to edit a program, we could edit one called test. Okay, or you know what, let's call it hello world. Alright, now we're in the in-game editor, and we can use the APIs that I mentioned earlier to write your own programs. So let's start writing a program. Let's just do a very simple one called print hello world. And if we wanted to, we could clear the screen before we print that by typing term.clear, and that clears the terminal. So the first line in this program will clear the terminal, and the second line will print hello world. You can see at the bottom it says press Control to access the menu, and you can have the option of save or exit, and you use the arrow keys here to change them. I'm going to save it, and then I'm going to exit the program. When I type dir again, or ls, either one, you can see hello world is now a valid program, and when I run it, it'll do exactly what we told it to. Clear the screen and type hello world. Pretty simple and straightforward. You can see it put it in the bottom there, but that's not a problem. It's just going to go at the current position that it was at. If I edit hello world again, and I want to do term.setCursor POS 1,1, now it's going to set the cursor position at 1,1, top left, before it writes hello world. So you can see it did exactly that. And that is the hello world program. I just wrote my own program. How cool is that? I can run it whenever I want and do whatever I want. Now the problem I mentioned earlier is when you break this block. It's going to go ahead and store that in that number 22 folder, but now when I place down the computer again, you can see that Hello World is no longer there, and the ID of this computer is number 23. So we kind of broke the computer and then replaced it. What we could do, let's go ahead and edit our Hello World program again. And again, I'm going to do term.clear. And I'll put a few exclamation points afterwards just to make sure we can tell the difference here. Okay, so we've got the ID of the computer, and we've got the Hello World program, which is working. We hope. Now, what we might want to do is set a label for this computer, and that's really easy. We just type the label command, and you can see that there's several usages of the label command. Right now I'm going to type label get, and you'll see that there is no label on this computer yet. So I'm going to set it as Hello World. Great. Now when I type label get, you can see that this computer is now labeled as the Hello World computer. Awesome. All I have to do now, when I break it and pick it up, you'll notice that when I mouse over the tooltip here, the computer ID is number 24, if you look in the NEI ID thing, and you can also see that it's labeled as Hello World. When I place the computer down again and check the ID, it's still number 23, and the computer is labeled Hello World. If we type dir, we can see the Hello World program is still there, and we can still function with it. So basically, if you want to be able to break and pick up your computers again and pick up where you left off, you want to give them a label. That's an important piece of this ComputerCraft aspect. Pretty cool. Alright, so short of writing a little program that says Hello World, what can we do with computers in ComputerCraft? Well, of course, at the very basic state of it, we can emit redstone signals from pretty much any side of the computer. All we have to do is open it up, and you can see there's a bunch of stuff on here. One of the built-in programs to do this is called redset. So let's do help redset. And you'll see that right here it's telling you some information. Let's clear the screen just so you can make it easier to see. So at the very fundamental area, you can do redset, and then the side that you want to emit a redstone signal from, and true or false to turn on or off the redstone. So if I do redset left true, watch the redstone signal state over here on the left. Ta-da! It just turned on. And of course, redset left false will turn off the redstone side. Awesome. You can also do another kind of thing called red pulse. Let's check the help on that. Red pulse outputs a pulsing signal, and you can do it on the left, for example. And if you just do 5, it'll do 5 1-second pulses, or if you do 5 and 0.5, it'll do 5 half-second pulses, or 5 2-second pulses, for example. Let's do 5 2-second pulses on the left. 1, 2, 3, 4, and of course 5. So at the very basic fundamentals there, you can go ahead and emit redstone signals from any side of a computer. And of course you could do redset right true to emit on the right side of the block. Pretty awesome. Now you might have seen this neat little setup over here. Of course, bundled cables can hook up to ComputerCraft computers because LRM basically gave Dan200 permission to set this up like this, and he did a whole bunch of work getting it working. So bundled cables can connect to the side of a computer, and you can kind of emit on the right side of a computer using the bundled cable setup. So let's take a look at using the programs that are already written, and then we'll write a program and show you one that we already wrote before to play with these lights that we've got set up over here. So one example, we could do redset, and you can see if we just type that, it'll tell you the different usages. So I'm going to do redset. On the side is right, because the bundled cable is coming out of the right side of the computer. And then we can do the color that we want to set. So I'm going to do white, for example, and then I'm going to set it to false. And that should turn off the white light. Awesome. And we can do the same thing for orange. And we can turn on magenta if we want by doing magenta true. So we can use these individual commands to go ahead and set our different color signal states, just like you've seen right here. You can also write your own API stuff. So let's do APIs and check out a help with redstone, I think it is. There we go. So you can see there's a Redstone API where you can get and set your output size for just vanilla Redstone, and then there's the APIs for the bundled cabling. So you can get the bundled cable input, and you can also set the bundled cable output and choose the side and the colors you want to emit. Pretty cool. Let's check out a program that I wrote earlier called Light Test. And what this will do is cycle through most of the colors with a few half a second delay or so. Pretty cool. I didn't go all the way up, but that's the basic gist. If we edit Light Test, you can edit existing programs, of course, by typing edit. You can see it's pretty straightforward. I just set the bundled output on the right to 0 as the first command, so it shuts off all the lights. Then it sets it to 1, which turns on the white light. Then it sets it to 2, which turns on the orange light. And then it sets it to 3, which turns on the white and orange light. So this is again your binary numbers and your outputted cables. Works pretty similar to the way Red Power 2 computers work in terms of the binary numbers coordinating with the different colors on your bundled cabling. And then of course 4 is just magenta and up from there. So let's exit this and try Light Test again. You'll see it turns everything off. White, orange both, magenta, white, orange, and then all the way up through there. So using ComputerCraft, you can interact with bundled cabling, like you saw here, and you can also interact with redstone cabling, or redstone wiring, just like that. It's pretty awesome. Now at this point in the mod spotlight, you might be wondering to yourself, why would I want to set up a ComputerCraft computer to mess with Red Power signaling when Red Power adds its own computers? Well, there's a couple good reasons actually. Number one, ComputerCraft uses a Lua programming language, which is a little bit higher level than Forth. So if you're struggling dealing with the stack-based programming language of Forth, or maybe it's just not your cup of tea, you could try Lua. It's a little bit easier to understand, a little bit easier to read, and it's pretty straightforward. The other cool thing about ComputerCraft is it adds a bunch of different blocks, such as turtles. Turtles are a lot of fun and really cool, and we'll get into how they work right now. So turtles, what are they? Basically, they're mobile computers that have their own set of APIs for moving around and doing all kinds of different stuff. You can see there's a bunch of turtles available to you. There's melee turtles and digging turtles and felling turtles, which has an axe on it for felling trees. And there's the farming turtle, and then there's some mining turtles as well to do some mining for you. There's all kinds of different ones available. And to create a turtle, you basically need to combine your computer with some iron and a chest. And then to upgrade your turtle to a different type, you combine it with the diamond tool appropriate. So if you want a mining turtle, you get a diamond pickaxe. And if you want a, for example, crafty melee turtle, or a melee turtle, for example, I'll get into the crafty stuff in a minute, you combine a sword with a turtle. Pretty cool. So that's your basic turtle. And let's craft one right now, or just give ourselves a simple turtle, and check it out. So this guy's pretty cool. Turtle OS 1.4 opens up for us. And we can check out, by looking at the list of programs, what's available to us. You can see there's more built-in programs with a turtle than there is with simply a computer. And you can also check out the APIs, and you can check out your help screen with the turtle API. There's a bunch of different turtle programs and things you can run. So that's the API if you want to write your own programs, but let's real quick just go over some basic functionality by looking at the built-in programs. For example, Go. The Go program allows you to tell your turtle what direction to move in. Pretty straightforward. And the other one is turn. So if you want to turn a certain direction, you can use the turn command. Let's try it out now. So if we want our turtle to move upwards, we just say go up. And uh-oh, it says it's out of fuel. Turtles do need a fuel source to run, and we're going to give them one right now. We can just go with coal, but pretty much anything that burns in a furnace will be available to the turtle. If we want to force the turtle to refuel himself, for example, just having coal in his inventory isn't enough, we have to issue the refuel command. And that'll set the fuel level. It uses one piece of coal, and it'll set the fuel level to 96. If we check our help with refuel, we can see that you can specify how many items to pull out by giving it a line there. So refuel 10 will pull 10 pieces of coal out of the currently selected slot, and refuel all uses up all the coal. And you can see the fuel level continuing to go up. Pretty awesome. Now if we want to type go up, we should see our turtle move up. How cool is that? And we can say go forward, and he'll move a block forward. We can say go forward 10, and he'll move 10 blocks forward. So you can see this turtle can do a whole bunch of different things in terms of moving. If you want to move him side to side, he can't directly move left and right, but you can tell him to turn right, and he'll do that. And then you can tell him to go forward, let's say 5 more. And there is a pretty much a built-in program called dance, and he's preparing to get down. Go, turtle, go. Oh yeah, dancing around. And this program will run until you stop it. You can stop a program by holding the Control and the T key to terminate the program. Hold it down for about a second and it'll terminate the program. You can also Control R for about a second and it'll restart the computer, or Control S for a second to completely shut it down. This works for both computers and turtles. Now you might be saying to yourself, Direwolf, you mentioned something about a mining turtle? What's up with that? Well, the mining turtle is pretty cool. He has the ability to mine rocks and ores. You can also use a digging turtle to dig through dirt and sand, but the mining turtle can handle dirt and sand just fine. One of the cool things that Dan200 has given us here is a built-in program for mining. All you gotta do is place your turtle directly in front of an existing chest. So for example, I'll just place this regular old vanilla double chest here. And if we look in our programs here list, you can see there's a program called Excavate right up here. And if we check the help for Excavate, you can see what it does. It's basically going to run until it hits bedrock, and it'll dig a rectangular shaft, and you can specify how big of a shaft you want to make it. So if we tell it Excavate 3, it'll dig a 3x3 mine shaft. Now of course your computer is going to need coal, but let's start the program now and see what happens. Excavate 5, let's say. Go. Oh, it's out of fuel. Poor little guy. So let's get him the coal that he needs. And run Excavate 5 again. Now, unlike other programs, Excavate has a built-in refueling function, so you don't have to worry about telling it to refuel. As long as he's got coal in his inventory, he'll find it and take care of it. And as you can see, he's kind of digging out a 5x5 area here. So right now, he's trying to figure it out, and then there he goes. And he'll dig out a 5x5 area, just like he had before. And the smart thing about this turtle with the Excavate program is it keeps track basically relative to where it started, and once the inventory, the built-in inventory in the turtle, this thing over here, fills up, he's going to go ahead and head straight up to this large chest, deposit his goodies, and go back to mining. In fact, let's help him right now to get that accomplished. Oh, no empty slots left, returning to surface. He's going to go up here. He's going to drop off all his goodies. And then he's going to go back to mining, right where he was before. Now, of course, the built-in Excavate function is a little bit basic, but you could, if you wanted to, go ahead and do some cool stuff. You can see right now I hit Control T. It noticed it was out of fuel before that happened, so it was going to head back to the surface, but I terminated the program. And you could, if you wanted to, mess around with the Excavate program, make a copy of it, and edit it to see how complicated it is. Turtles don't have to just dig, like this one, for example, that I just showed you. I'm going to go into the built-in Lua interpreter here. If we just type LUA, Lua, like that, you can go ahead and send commands as if you were writing code, but send them directly. So I'm going to tell this turtle to dig down. Note that it returns false because there is nothing below it to dig. But if I tell it to move down, like this, it returns true because it was able to move down. It now returned false because it can't. And if I tell it to dig down again, it responds with true. So most turtles that have a tool can dig with the dig down command. However, if you've given this tool a hoe to the turtle and made him a farming turtle, you can go ahead and tell this guy to dig down. And what he'll do is till the earth below him. So instead of actually breaking the block, he'll till the earth. Pretty sweet. And if we wanted to, we could give him some seeds, like this, and let's even put a bucket of water right here. If I told him to do the following, turtle.placedown, it'll plant the seeds directly under it. So you could write a little program here for your turtles to go ahead and automatically harvest for you. And when we're done with this, we can tell it to turtle.digdown again, and it'll harvest those seeds for you. Now the seeds just didn't happen to drop, so that's not a big deal, but it would have gone in the inventory if it was a fully grown piece of wheat. Let's demonstrate that now. Ta-da! Picked up the wheat and the seeds. So this turtle can do all your farming for you, if you wrote a pretty cool program to do it. This turtle over here is another example of something cool. This is called a Crafty Turtle. And what he does is he can craft for you. All you have to do is open up the inventory here and make sure that he's got certain items in his inventory. So for example, I've placed items like this. This is the recipe for a furnace. And if I just open up the low interpreter and say, hey turtle, craft. Boom. It'll craft the recipe that it had in its slots there. Pretty sweet, isn't it? Oh yeah. And you can craft pretty much anything as long as the items are relative to each other in a 9x9 grid. They don't have to be in the top left here, but it's probably easier if you do place them like that. And if you want to have your turtles get items in order to go ahead and craft something for you, you could simply check out over here. I've got a turtle sitting in front of a chest. Now this turtle is pretty cool. What you can do with this one, I'm going to open up the Lua interpreter. First off, we can do a command called turtle.suck. And what that'll do is if there's nothing in front of it, it'll try to pick up any items on the ground. But if there's a chest in front of it, it'll try and take items out of the chest. And it'll start with the top left slot. And if there's no items in the top left slot, it'll move over to the next one and kind of proceed until it finds something. So over here, I told this guy to turtle.suck. We should find about 64 items of cobble landing in the inventory now. There it goes. And it placed it in the currently highlighted slot in the inventory. In order to change the currently highlighted slot, we use turtle.select. And we pass it the number we want to give it. This is number 1, 2, 3, 4. So if I wanted to select slot number 4, I could do that. And you can see it's now highlighting slot number 4. And 16 is the bottom right. And if I wanted to place these items back in the chest, I could do turtle.drop. And if there was no chest in front of it, it would drop them on the ground. But since there is a chest in front of it, it placed them in the chest. Pretty cool. You can also use drop down to place items in the chest below, and drop up to place items in the inventory above. Drop up is a nice way to have your turtle fuel a furnace, for example. If I were to place a furnace here, put some coal in the bottom right slot, and tell the turtle to drop up, note that it returned true because it was successful, and it placed the coal in the furnace. Awesome. You can also compare slots in your inventory by using the turtle.compare. Turtle.compare to, and you give it the slot you want to compare with. So right now I've got slot 16 highlighted. I'm going to put a piece of cobble in there. Now I'm going to compare it with slot number 1. And notice that returned true because the items in slot number 1 are the same as the items in slot number 16. But if I compare it with slot number 4, for example the wool, it should return false. Armed with this information, we can use this turtle to sort. Note that I've got cobblestone inside this chest. I've written a program called compare. And basically what it does is it goes to slot number 16 here, and then it pulls the top left item out of this chest. And then it'll go through each of the different 15 slots and compare them to slot number 16, which in this case will be cobble. And if they're the same, it'll drop it in the chest. And then it'll jump to slot number 16 and drop that in the chest. So basically what this will do is it'll only place the cobble in the inventory here into this chest, and it won't place anything else. Let's try running the program now. Compare. It pulled out number and placed it in the 16 here. Now it's dropping all the cobble in the chest, and it placed number 16 back. Pretty awesome. Everybody likes their neat little door mechanisms. Let's check out a password protected door. This is a pretty simple program. Right here you can see it's asking me for a password, and I can type in the passwords that I might want to try. Test didn't work. Password, no such luck. Help? Nope. The password is DW20. Boom, it opens the door for just a few seconds and then closes it automatically behind me. How'd that all happen? Well, it's pretty simple. And I'm going to terminate out of the program now. There is a way to prevent people from terminating out of your programs, by the way. But I wanted to show you how this worked. I've got a door pass program that basically continuously loops with a while loop. It clears the screen, sets the cursor position to 1.1, and prints enter password, just like the Hello World program did. And then we create a variable called input and read the input from the screen. And if I had typed in DW20, then it outputs a redstone signal to the left, waits about 3 seconds, and then turns off the redstone signal. And then it keeps running over and over again. Now, one thing you might have noticed is that when I was typing in the password, you could see what I was typing. But if I wanted to, I could come over here and do this. And this will prevent anybody from seeing what I type, because it'll replace whatever I type with a star character. So let's save this program and run door pass again. Now when I'm typing in the password, you can't see what I'm typing. But when I enter DW20, boom, the door opens and everything works. Pretty awesome. Alright, I couldn't do this mod spotlight without building a turtle that does the following. Check out this program that I wrote called 9x9. It actually goes ahead and builds a 9x9 house for me. It's pretty cool, a little bit complicated. It took me a little while to write, but honestly, not so bad. Let's go ahead and run it right now. It just needs a bunch of cobble and some glass in the bottom right slot. Let's try 9x9. Go! Good job, Mr. Turtle. So here's a neat little turtle I've got set up with a program that I personally wrote, and I don't mind telling you, I'm a little bit proud of it, even though it's rather basic. But I'm going to call it 9x9. And what it does is build a 9x9 for me. It goes ahead and creates walls, and does a whole bunch of cool stuff. It automatically refuels itself, and it's a little bit complicated, but maybe I'll post the code for you in a paste bin for this video so you can check it out. But honestly, it's very straightforward. A couple people have written 9x9 programs that are way better than this, but let's go ahead and run it and see how it works. What it's going to do is it's going to start in the top left slot and then start building walls. Basically, I have it going out 8 slots and then turning right and going 8 slots to there. And it's going to build a 9x9 for me. Check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it builds this nice little 9x9 house. And don't worry, it will build the roof. Here's where I was testing it building the roof a moment ago. Pretty sweet, huh? So I'll come back in a minute once that guy's done building and we'll see how he made out. But for now, he's just going to go ahead and build. So it looks like my turtle has built a 9x9 that's 4 high, and he's going to go ahead and start building the roof now for me. Good job, little turtle. I'm very proud of you. He does a pretty nice job, even having placing in the glass skylights. And then, of course, he places a row of cobble, turns around, and creates 2 more sets of skylights for me. And ta-da, he's all done. So I've got this nice little 9x9 built. He doesn't place a door, but he definitely could. I've seen programs that people have written online that are way more better than mine, way more complicated and much cooler, that'll place torches and a door, and I think it even places the pressure plate for me. You can check them out. There's a forum for ComputerCraft where you can check out some programs other people have written. So if you're not terribly good at programming yourself, you can go ahead and download some programs. They're all in text format. Speaking of programs, the cool thing about it is you can actually go into the folder that I mentioned earlier, the ComputerCraft folder. There's a computers folder inside your world save, and every computer or turtle that you've created, like I mentioned, has its own ID. And there's a folder for each computer with that ID name, and you can go in and check out the programs that you've written in there. So if I go into this folder, I'll see a 9x9 text program with all the code inside it, and I can edit it outside the game. It makes it a little bit easier if you want to edit in WordPad or Notepad++ or one of your other favorite text editors. And you can also copy files from one computer to another that way. But if you wanted to copy files from one computer to another in-game, that's not a problem either. We just go over here to this little machine called a disk drive. Pretty cool. Disk drives, as you can see, are created like this, and you can create yourself a floppy disk. All you have to do is place a floppy disk in the drive, so let's get ourselves one and place it in there. Now, remember when I typed dir earlier on a computer, it listed all the contents. By attaching a disk drive to a computer, there's now a disk folder over there. I can go into that disk folder, and you can see there's nothing in it right now. If I want, I can copy light test to disk. Ta-da! Now the light test program is on the disk in the drive. Cool. I can also, if I want, label my disk. Label set, and then the drive is on the left, so I'm going to say left, and let's call it the light test disk. See if that works. Hey, look at that, light test disk. Awesome. I can now take this light test disk out of here, head over to any other computer that has a hard drive hooked up to it, a disk drive. Right now I'm going to do dir on this computer. You can see there's nothing on there. All I have to do is place my light test disk in the drive and say dir again. You can see now there's a disk in there. So I'm going to copy. I'll go into the disk folder. Copy light test to .. Now I've copied the light test program to this computer. No more disk because I took the disk out of the drive, and light test, if there were something hooked up to it, would work, but there's no wires obviously. So that's how you can copy a program from one computer to another in-game. Works pretty straightforward and it's pretty cool. Another add-on peripheral to your computers are called monitors. These guys are really cool. Check this out. It's a monitor, and I'm going to go ahead and give myself a few more of these guys. All you gotta do is place it down on one side of the computer, and then you open up the interface here, and if I do a help on monitors, you can see that you can do two things. You can either run programs in it, or you can, for example, edit programs in it if you want. I've already created a program on this computer called Sample 1 and Sample 2. Let's check out what Sample 1 does. It just writes the word test. So I've just edited the program to change the cursor position. Now if I want to output that on the monitor, for example, the monitor on the right of this computer, I just type monitor right, and then the name of the program, Sample 1. Cool, so it output the word test on the monitor. Let's check out what Sample 2 does. Sample 2 writes, this is a test, monitors are awesome, keep away from water. Good plan. Let's output on the monitor on the right, the program Sample 2. Oh, looks like that monitor didn't have quite enough space to list the whole program. Not a problem. I'm going to run monitor right clear, and that'll clear the monitor. The cool thing about monitors is you can extend them by just adding some blocks on the side, and they'll kind of automatically grow. As long as you've kept them the same number horizontally, you'll note that all of a sudden it becomes the same monitor. How cool is that? Dun, 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 dun. So close. There we go. So now I've got this big old monitor right here, and I can try that monitor right Sample 2 again, and you can see it's going to use this whole monitor setup that I created as all one large monitor. And you can output all kinds of text here and all kinds of information. It's really pretty awesome. One last function I want to show you guys is called the GPS function. I've actually got several computers set up around here, and they've got what are called wireless modems on the side. Pretty cool. A wireless modem is crafted like this. All you have to do is get a computer, like so, and place your wireless modem on any side that you want. Wireless modems are pretty cool, but they're also pretty new, and that is a monitor, not a computer. If you want to turn on your wireless modem on a particular side, you go into the Lua command prompt here, and you do rednet.open, and then you tell it what side you want to open, for example on the left. But you have to use lowercase. Capitalization counts in Lua. And look, now it's got this little red border on to indicate that this computer now has access to this wireless network. And if I wanted to, I could get another computer here and hook this guy up. Now both these computers are opened up on the wireless network. Now if I go into this computer and do a help on RedNet, you can see there's a bunch of different ways you can send messages and receive messages across the wireless network. All I have to do is know the computer ID or broadcast a message to all computers that have an active wireless modem on them. So right now I'm going to head over to this computer and I'm going to check out the ID of the computer. Just another way to do it in Lua. So this computer's ID is number 30. So now I'm going to do rednet.receive. And now it's going to sit here and wait to receive a signal over RedNet. Cool. I'll go over to this computer and I'll do rednet.send to computer number 30, the message, hey there, number 30. Boom. That needed to be done in Lua. And it received true because it successfully sent the message. Over here we can see that we received a message, hey there, number 30. Pretty cool. And I believe number 23 there is the computer that sent it. So you can see that this is number 23. And you can see it said, hey, I just got a message from number 23. Hey there. So you can write some programs to communicate wirelessly between two computers. Also, you can do this with turtles, as there are some turtles that have a built-in wireless modem. So you can see wireless turtle, wireless mining turtle, that kind of thing. Pretty awesome. And finally, you can use wireless modems to create a GPS network. All you need is a couple computers dedicated as GPS hosts to host the GPS signal, and then you can use computers with wireless modems in them to figure out exactly where they are. For example, this guy's got a wireless signal, and if I type GPS locate, it can figure out its current position. The way it's doing that is there's 4 or 5 computers out in the field that it can communicate with that are hosting kind of a GPS server. This guy is currently hosting GPS, and its current position, the XY coordinates here, are shown. So you can see this computer's position is 407, 65, negative 116. Correct. And by having these different computers set up around the world, and even one up here, all the way up high, so it can figure out its Y coordinate. This computer down here, there's one more GPS host. This computer down here has the ability, this is actually a turtle, to find its position based on those different hosts. And if we wanted to, we could write a little program to figure out its current position and then move to a position given coordinates. So if I wanted to, I could write a program that said, hey, go to, I don't know, 350, 65, negative 110, and it would find its way there. I don't have a program like that written, but you could easily do it. Alright guys, I think this is a pretty good wrapping up point for the ComputerCraft Spotlight. Pretty much I've touched on the basics, all the different things computers can do. You can connect with monitors, you can connect with floppy drives, you can connect redstone signals and bundled redstone cabling with red power. You can have turtles that are basically little robots that do almost anything you can imagine. Almost anything a player can do, a turtle can do if properly programmed. They can mine, they can harvest, they can till the fields and grow some wheat. They can compare inventory with chests. They can drop blocks, and they can even build a 9x9, or anything you want for that matter. ComputerCraft is a really awesome mod written by Dan200. You're going to want to check it out by going to the forum link that I post in the description of this video. Like I said, check it out. It's really cool. And if you're interested in doing some programming, it's really neat. If you're a little intimidated, don't worry. It's actually easier than it sounds to get started with this stuff. And if you're interested in getting into programming, this is as good a time as any to start messing around with ComputerCraft. You can check out the wiki and the forums that he has linked in his main Minecraft post, and you'll see a bunch of sample programs that other people have written that you can easily download and use, and there's pretty much no harm to your computer by doing it. So I hope you guys enjoyed checking out the ComputerCraft Mod Spotlight. This is Direwolf20 signing off. Take it easy.